Now we have a presentation session by Shridhar Dharmarajan, Executive Vice President and Managing Director, India, Manufacturing Intelligence Division, Hexagon, on enabling e-mobility ecosystem, turning disruption into opportunity. Over to you, Mr. Dharmarajan.
Welcome to the ETAuto Electric Vehicle Conclave. I'm Shridhar Dharmarajan, EVP and MD, Hexagon Manufacturing Intelligence India and MSc Software Indo-Pacific. Today, my focus of the presentation would be how do we enable the e-mobility ecosystem in India? There's so much of disruption happening in various industries, especially the automotive industry, which is facing a lot of disruption. And COVID has actually accelerated many of these disruptions. And how do we ensure that we turn this disruption into an opportunity rather than being stressed about this whole disruption activity? So let me just give you a different perspective to this whole thing. Normally, any disruption that happens, our perception is always the disruption is happening in a linear fashion because we are so busy in doing things quarter after quarter after quarter. We perceive that, yeah, we know change is happening, but change is happening in a linear way. But the reality is change is happening in an exponential way. Now, the gap between the reality and the perception, you can look at it like a stress, or you can look at it like an opportunity. And these are the events where new technologies are born. These are the events where men get separated from the boys. And if you notice, even the stock market for the last 1 year has been phenomenal. And if you notice, those companies which have used this difference as an opportunity have really thrived. And some of those companies are stagnating or actually going down. So let's look at the disruption happening in the electric vehicle space. This is the data from Bcg Analysis. Bcg predicts that we're going to grow by 5x in the next 10 years. Okay. And it also predicts there'll be about 600 EV models that will be launched in the next 5 years, out of which 450 will be battery electric vehicles. This is phenomenal. But at the same time, if you really look at the graph per se, it is still predicting a little bit from a linear perspective. Okay. Again, we have to start questioning ourselves. Is this electric vehicle disruption happening in a linear way, or is going to happen in an exponential way? And only time will tell. And this is a major change. So automotive industry is going through a major disruption, whether it is electric vehicles. So what happens is when you have the electric vehicles, now the entry barriers to making an automotive vehicle is actually reduced. So if you notice, there are many startups in China and slowly startups in India as well are really looking at getting into the automotive space. We saw in the two-wheeler space, companies like ETAuto coming and storming in India. And if you've seen China, if you see Google getting into the automotive sector, if you look at Apple getting into the automotive sector, this is going to be a major disruption to our established players like the BMW, Audi, the big three in the US. And this is the changes that we're seeing. So you're going to see some very new players who have not had that much experience in the automotive space to really work on it. And there's an opportunity is going to come for all these people to really increase their revenue in a dramatic way. So let's look at this whole e-mobility design challenges. Let's look at the power density. It's very, very important out there. Now, when you have the internal combustion engine, the noise of the engine is so high that it subsumes all the other noises in the vehicle. But when this noise goes away and you replace the internal combustion engine with electric vehicle, what really happens is, the high frequency noises, especially when you press the brake and you got the squeal, that really disturbs the passenger experience in the car. So you need to take care of this. So NVH characteristics become very important. This is interior acoustics. From an exterior acoustics perspective per se, these cars become so dangerously quiet that you need some kind of a detection from a pedestrian safety perspective when the pedestrian is moving in front of the car. Today, when you're walking on the road, you kind of hear the roar of the internal combustion engine, and you can kind of step aside if it is really required. But if your electric vehicle is coming behind you, you may not even hear the noise. So then you have to have some specific requirement, which is already becoming a regulatory standard in the European community today, where when the car detects a pedestrian in front of it, it should start making some new noise so that the pedestrian is aware and he kind of steps aside. This is very, very critical. So NVH becomes very, very important in the electric vehicle design. Durability becomes very important as well. If you really look at it, where do you position the battery? What should be the size of the battery? So in the initial stages of electric vehicle, we always had this range anxiety. What will be the distance the car will travel before the charge really goes away? Today, people have addressed, we have this lucid motors claiming that one charge will do about 500 miles. Tesla is also kind of talking about high range. And so once we start looking at it, what should be the size of the battery? Where should we really position on the battery? And will this really affect the total durability of the car? What will be the life of the car? Some of these characteristics are pretty important. How efficient are we? How are we designing these vehicles in a more efficient way today? Because today, just look at the situation of an automotive design engineer. What are the compulsions? What are the constraints that is coming into? When electric vehicle comes into play, then we have the BS6 norms, and then we have the CAFE norms. You have corporate average fuel efficiency norms coming into play. Then we have, the autonomous, because as soon as electric vehicles come into play, autonomous also comes into play. And autonomous can be level 1 to level 5 autonomy. So he has to really take care of all these activities when he's actually designing the car. So he should not only focus on the optimization, focus on durability, focus on NVH, focus on all these various characteristics in designing the car. This is where the architecture comes into play. How exactly will be the new architecture of the car? Where will you place the battery? How many electric motors do you use? Will you use one single motor? What will be the transmission? The transmission to the four tires, how is the transmission actually taking place? So this whole architecture definition is going to be very, very critical. And this is some of the skill sets that our new automotive engineers have to really gain. And to really help these automotive engineers, we are introducing many of these courses in electric vehicles in academic institutions so that people who pass out of this mechanical engineering or automotive engineering courses are pretty skilled for them to design in this complex environment, in this disruptive environment. At this point of time, I just want to give you a brief introduction of what exactly Hexagon is and what do we do today. If you really look at Hexagon, Hexagon is a global leader in sensor and software and autonomous technologies. And we are in the, if you look at our tagline, we empower an autonomous future. Whether it is cities, whether it is automotive, whether it is aerospace, whether it is mining, whether it is agriculture, we want to ensure that we create an autonomous world. What do you mean by autonomous here? Autonomous is nothing but cognitive automation, which is intelligent automation. So if you really look at how the industry has grown from industry 1.0 to today 4.0, you had this mechanization taking place, and then you had automation taking place, and then you had connecting all these machines together, which is industry 4.0, and trying to see if the data, which we say that, how do we ensure that we use this data effectively to take decisions by itself. So empowering autonomous future is very, very critical. And can we use, we keep calling the data as a new oil. If the different machines in your whole plant understands the data that is generating by itself, and giving you a feeling that I'm going to fail after so many cycles of operations, and ensure that we take care of the predictive maintenance aspect of it and replace the machine or repair the machine before the machine actually goes down, that's going to really kind of impact your productivity of the whole plant. So we are empowering an autonomous future in various industries, and that's our tagline and that's our goal to do. So we have come a long way to give you a perspective, just 2 slides on Hexagon before I move back to the technology area. This is very important for you to understand where we come from. So if you look at in the 95% of the automobiles produced today in the world today has Hexagon technology in it. So if you take Honda, Toyota, the big three in the US, if you take Audi, if you take BMW, and even in India, if you take Tata Motors, Ashok Leyland, Mahindra, and Maruti Suzuki, Hexagon technology is definitely there in place. 90% of the aircraft produced globally has Hexagon technology, and 85% of the smartphones produced have Hexagon technology. So this is a very, very critical space. These are the areas that we really kind of focus on. And what this really means is Hexagon is a true technology company creating an autonomous future for all these various industries. And I really like to call Hexagon as a phygital company because it has hardware for the physical space and it has software for the digital space. So if you want to enhance your existing infrastructure, whether it's a plant or a factory or your own vehicle, then you can actually scan all these existing infrastructure, take it in the physical space. We have various cameras and scanners. We have some CMM machines which can even measure up to 1/10 of a micron, which is less than a strand of a human hair. We have contact measuring machines. We have non-contact measuring machines. We have optical measuring machines. And these technologies, so this can operate in the physical space. Once you scan it and take them to the digital space, you can optimize the whole design and go back and implement in the physical space. Or if you're starting completely in a greenfield environment, a green new platform completely, you can operate in a digital space and then come back and create them in the physical space. So that's the area that we operate. So now let's get back to the technology side. Let's really look at EV per se. So if you look at it, the way we are looking at EV is from a holistic perspective. We are trying to ensure that we take care of the electric motors, we take care of the drivetrain, we take care of the power electronics, we take care of the battery and the fuel cells. So these things are very, very critical. So today we have technology in software and hardware to ensure that we have a digital twin of almost every part. And we can simulate, whether you simulate the performance of the part or how is the manufacturability of the part. So if you really look at it, any part that you take, for example, this part that you take, how do you say the quality of this part is pretty good? When it was the touch and feel of the part, so it's essentially, whether it is touch and feel is actually talks about the surface finish, which is really taken care by our Hexagon production software. And what is the performance quality? So what happens when I drop this part? What are the stresses? What's the vibrations? Essentially, when an automotive car goes and crashes at 200 kilometers per hour, to a wall or some other vehicle, we can accurately predict what's the deflection, what's the stresses, what's the temperature in the vehicle. So you can today create a digital twin of not only every component, but of every process. So you can literally create a complete vehicle in a digital space before really manufacturing the physical space. So the whole idea is the perceived quality is taken care by our manufacturing division, and the performance quality is taken care by our design and engineering division. So this concept of your as designed part, as manufactured part, as measured part, can it be one and the same? Because the designers may say, I've designed a great part, manufacturers may say, I've manufactured a great part, but ultimately our metrology division, Hexagon, has really started off from a metrology and the measurement as a measurement company before we started looking at a holistic manufacturing intelligence per se, as we really call it, where we are talking of smart manufacturing and creating parts in a smarter way. So we are linking all these design and engineering department, your production department, and your metrology or inspection department, and trying to help our customers to ensure that their as designed part, as manufactured part, and as measured part is one and the same. This is very, very critical out there because we are connecting all these things through a digital thread and ensure that can we learn from the data generated by each of these divisions? Can we learn from the data generated with the process between the two divisions and ensure that we get the part right out the first time, and also ensure our whole product development cycle is much lesser and we can manufacture it at a much faster pace. So also looking at the new materials activity, because when it comes to electric vehicles and even autonomous vehicles that they will talk about, we want to start creating, can we really create lighter vehicles, for if you really want to meet your CAFE norms perspective, you have to start thinking about, can we replace our homogeneous metals like steel or aluminum with FRPs or fiber reinforced plastics? And these are some of the new technologies. So we have a dedicated material division to start simulating what will be the material properties, because once you use the fiber reinforced plastics, the material properties are going to change not only at each point of the part. So all material properties depends on the direction of the fiber and the length of the fiber. So you need a simulation software to ensure that first you calculate what is the material property at various points of the component before you start subjecting it to the boundary conditions and the load conditions, and start understanding how this part will actually behave based on the different external environment and different external stimulus that is actually facing. So we talk about trying to create some new materials, talk about cabin interiors, what should we, we spoke about interior acoustics, exterior acoustics. How about the aerodynamics part of it and the whole body structure part of it? And when we are doing all these things, if you really notice, we are really taking care of the not only the design and engineering space, at every stage, we're taking care of what happens in the manufacturing space. So if you are welding the two components to make an assembly, or if you are doing a forging process, a forming process, or if you're manufacturing in an additive way, you can simulate the entire manufacturing process as well. So it is very important to do this in the early design cycle, because your 80% of the cost of your car is actually committed at 20% of your product life cycle, because you are deciding what materials you're going to use, you're deciding what kind of manufacturing process that you're going to do. So all those costs are committed upfront. So any change in the later product life cycle is going to be phenomenally expensive. So we have to really look at from a holistic perspective. So while you're designing the car, ensure that you're able to simulate the manufacturing activity as well, so that you're as designed, as manufactured, and as measured part is one and the same. So if you look at the various aspects of it, we are looking at a totally holistic environment. One thing you should know, that whatever disruption this EV is causing, we must understand the car is still a car. It has to ensure that increased comfort is there. Your vibrations inside the car, your ride and handling should be comfortable. Your air conditioning inside should be comfortable. And you should obviously be more safe. But especially when you come to the EV and when you come to autonomous of course can be level 1 to level 5 autonomy. And in level 5 autonomy in a driverless car per se, we as humans readily accept any accident caused by a human negligence or human error, but we are not ready to accept any accident or any fatality caused by a machine. So how safe is a question. So all these emotional things also comes into play. So you have to ensure that as you are going into all these aspects, you have to ensure that the cars have to be safer as well. Increased value for money. This is always a constant quest from in various companies. Can we do more with less? Can we deliver more value to the customer with less? So we have to ensure that every new platform that we generate, it generates more value to the customer. At the same time, it costs less to the customer. This is a constant journey that we are on, and this really comes into place to ensure that we do try to use some new materials. Also, try to really try to simulate the part in a realistic behavior. So if you look at one of our divisions, MSC Software tagline is simulate reality and deliver certainty. So we are able to simulate what is the realistic behavior of that particular vehicle in an external environment, and ensure that we deliver certainty the results, we predict how it is going to behave in a digital way, and we can optimize the design. So we need not have to design maybe 10 years ago with increased factor of safety. We can take care of that. We can actually do more with less materials as well. And also when it comes to EV, it's always to ensure that we keep increasing the range, and we don't have this range anxiety in the people who are driving these electric vehicles. So we really want to move away from this hybrid. So today, if you really look at the transformation, we are having this mild hybrid, or full-fledged hybrid vehicles where you have the IC engines and the electric vehicles. That's going to make the whole car much more effective as well. We believe the future is going to be a battery-operated electric vehicle, and that's the reason why this range anxiety has to be addressed, and it should be very, very critical for us to ensure that the car behaves. If I say that in one charge it's going to go 500 miles, it has to go to 500 miles. There's no questions about it. So to really re-emphasize, we have to design this whole electric vehicle in the total ecosystem. So we call within Hexagon 100% focus, 100% electric vehicle. So we have a holistic suite of solutions for design and engineering, production, metrology, while we take care of the customers and the suppliers ecosystem as well. Because if you notice, if the OEM is go through a disruption, the supplier is going through a much more multiplied disruption as well, because he has to also adopt to the new technologies, to the new areas, and he's very critical. And the more and more OEMs are depending on the suppliers, because in these disruption, what is happening, the OEM may not know much about a particular component which the supplier is supplying himself. The supplier has more knowledge and intelligence for that particular component. And this is the reason why we have to ensure that the customers are integrated, because tomorrow we will get into a place where a customer will actually get a unique car for himself. He can go to a automotive company's website and say, these are the things I want: a Goodyear tire, I want a dashboard from Aptiv, I want a steering from this particular company. He can pick and choose and get a dedicated vehicle for himself, and that's the direction that we are going to go. So we are going to have a customized vehicle. So, and technology is available today to ensure that we don't provide a generalistic vehicle, but we provide a specific vehicle for each customer, which is very unique. And that's the reason why customers also have to play in a holistic design as well. So re-emphasizing on some of these aspects, so we have to ensure that whether it is batteries or power electronics, drivetrain, the electric motors, the cabin interiors, all these things have to be considered. And Hexagon has got technologies to really design, manufacture, and measure these various components of this whole electric vehicle. That's why we talk about our strategy as 100% EV per se. So coming to our Powertrain Solutions, we have a very interesting company within our family called Romax. So Romax stands for Rotating Machinery Experts. And these are the people who have done some pretty great work and with all the leading EV companies out there to ensure that the electric motor design, the bearing design, all these things are taken care of. And how do we ensure that we optimize this whole powertrain architecture solution while taking care of the life of the component, while taking care of the manufacturability of the component, also taking care of the thermal management, because when you have this battery, that it really creates so much of a heat source within the vehicle. And how do we ensure that this heat source is managed? How do we design the whole cooling environment per se to really take care of the effectivity and efficiency of this whole electric vehicle aspect of it as well? So while we are speaking of the design and engineering and manufacturing, it's also very important to really look at our inspection division or the metrology division. And we will still have to measure some of the parts that we have manufactured. I know while simulation software always says that my vision is to eliminate testing and directly go from design to production, but the cars are also getting more and more complex. And as we eliminate more and more tests, you will always have some new tests you'll have to do for the first time to ensure the integrity of the whole vehicle. And that is where our metrology comes into play. So you create some prototypes, measure this, and you do some data analysis, because it's very critical per se, where based on whatever assumptions you have made, what is the kind of output. And there's a statistical analysis. There is a very interesting product called QDAS, which is being used by all the leading auto manufacturers and helps you to correlate between the assumptions made and the quality of the final part that is actually delivered. So when we talk of electric vehicle, automatically we go into an autonomous space, because this is going to be the future. And this is really important because I'll be talking about why autonomous and why electric is going to be important. And today we have the technology to really kind of scan the entire environment through which the car operates. So you scan the entire environment and say, this is the building, this is a school, this is a pedestrian crossing in this particular way, so this is a signal. So you scan the entire environment, and then you start simulating your driving. So when I'm talking about level 5 autonomy, already some countries like Singapore are far ahead. They are talking of almost 100% autonomous vehicle by 2030, 2035 timeframe. And we are one of the leading partners to really help them to achieve that. And they are also taking care of some of those drivers of these taxis today. They already started to train them so that when their job gets taken over, they can actually place somewhere else. And so once you scan this whole environment, we can simulate how the car should behave in this environment, and this whole data. Because what happens is when you're driving manually, when you're turning the steering, you know what kind of effort that you need to make to turn in a particular radius. But when you're talking of a driverless car, the car has to take a decision as to what should be the effort that it has to take on the wheels for it to turn perfectly. And these are the simulations that you can do, and all these simulations get captured through our AI engine and the machine learning engine, so that tomorrow when the car faces a situation which is not being simulated per se, it will behave based on the previous experiences, the previous knowledge in an accurate way. So we have the hardware to scan this whole environment, and we have the simulation software. And here it's all, we need to simulate in a real-time environment, because the car, it's not that you have time how the car should behave based on a particular situation. So the simulation is also happening as the car is being driven, and this whole thing can be managed, and this knowledge can be taken in a particular hardware, and you can put this hardware in a particular car and make a car autonomous. And why we have to do all these things today? Because if you really look at it, some of the statistics in India in 2035, We're going to be a $10 trillion economy. I wish and pray we'll be much more than that. One of the aims that we want to see whether we can get back to the 25% of the GDP what we were before the pre-British era, and we are working towards that as well. But this is the prediction. Population is going to be 155 crores. We believe as the literacy goes up, population will come down. So maybe we'll hit a high of 155, 160 crores, and then we'll slowly start coming down. Urban congestion is going to go up. Let's take Bangalore itself. We're going to have a population double of today. And so these are the things that is really happening. So we have to manage congestion. We have to reduce emissions. We have to obviously reduce dependency on oil. We have to ensure that we are safe. And how do we ensure that we reduce human involvement? And some of these things we have today one of the highest accident rates in India, about 1.5 lakh fatalities that is happening in India, and roughly about close to 4 times that of accident that is really happening. So this goes to about roughly about 400 people who die every day on our roads. And autonomous vehicle is the way to go, because autonomous vehicle, when we face an objection, it's just going to stop. It's not going to move. So autonomous is the way to go. So even if we say that we won't allow a level 5 autonomy in India, it is going to come at some point of time. And level 5 may come in a controlled environment like a golf courses or airport. But the more and more autonomous comes, even if ADAS or active safety will reduce the number of accidents, because even if the driver is losing control, there will be some mechanism internally which will take over and ensure that there's safety on the roads in India. So it's inevitable. EV will automatically transition to the autonomous world. So I would say the time is right, and we need to do this. I guess we don't have a choice. And I would also say that let's get it done. Today, India is pretty unique. We have the huge amount of engineering talent, and I strongly believe in the ingenuity of some of our engineers out there. And software development, I don't want to say we are already the leaders in software development and smart AI. If you really look at it in Bangalore, we have about 40,000 startups in India, many of them focusing on a lot of interesting AI technology. And we need to really get all these things together. And this is what we call it engineering convergence that we are working on, and to really help our customers to deliver their cars faster and right the first time, safer, much more efficient from a fuel efficiency perspective, and from an overall integrity and architecture of the car. So going forward, you're going to have a two-speed world. People who really take this disruption as an opportunity, they're going to change, they're going to innovate, and they're going to come up with new vehicles with new technologies. And people who are not going to change, they're going to stagnate or they're going to go down. And so I would say that let's choose to be innovators. Let's innovate. And I would say India is a great place to do this. Some of this disruption. I always say when the economic disruption happened in 2008, China became a new economic leader, and their GDP was $3 trillion in 2008, and today their GDP is $15 trillion. And this today's COVID disruption is not only an economic disruption, but it's also a combination of a health disruption, so health and economic disruption. Can India use this as an opportunity to innovate and lead the world and grow much faster what China did in the last 12 years? There's an opportunity. I urge each one of you to be innovators. Let's get it done, guys, and let's take this country to a greater heights. Wishing you all the best. Thank you, Economic Times, for giving this opportunity for me to speak on this forum, on this electric vehicle conclave. Thank you so much. Wish you all the very best in this journey. Thank you. Thank you all.
Thank you, Mr. Dharmarajan. With this, we'll move to the last session of the day. Stay tuned and keep tweeting using the hashtag ETAutoEVC.